Hello and welcome to Hand in 3 to 4. I'm gonna go through the different fillers one by one. I have maximum recording time of 15 minutes per video because of the program I'm using, so I'm planning on recording 2 videos and uploading them on YouTube, each 15 minutes long. This is the first one. And the first filter is the invert filler. Go through it here very quickly. So I will not go through the header in all these different filters, since the header is usually pretty much the same except for maybe declaring a variable or an array or something like that. So let's see why this quickly is loading. There you go. Alright, so all this on the setup is pretty basic. You just set the cam width and cam height and all the basic stuff. So what this filter does is try to run it. While it's loading, I'll explain. What it does is basically it takes the value. There you go. So it takes the value of a pixel and subtracts that from 255, and that creates the inverted color for that pixel. You can see here. Here we calculate so the pixels for the use so far followed later on, and we do that by dividing the cam width with the cam height and times 3 because of the 3 colors. And here we have a for loop that goes through all the pixels and sets each pixel to 255 minus the pixel's value. And that's basically it. Here we have functions to actually produce the image, draw the image. That was the first one. Brush and road filler. So the brightness filler I'll go through very quickly because it's very simple. Here we go. All this filler does is basically add let's see if I can find it. Where did I put it? Basically it goes through all the pixels once again. And it adds in this case a brightness of a value of 100 to each pixel. And here we just check if the pixel is more than 255, it's going to set the pixel to 255 because we don't want it below 255 in order for us not to exceed the maximum value that the picture should produce. And that's it. Very simple. The contrast is another very simple filter as well. What it does, and I'll show the different lines of code, but what it does is it basically times a certain value. The pixel value. Put the value I'll show you right here. So here we go through all the pixels again, and we assign a variable with double a data type of double. And here we set it to 0.5, so that it actually in this case halves each pixel's value. And why this increases contrast is because say we times 2, and if we have a low pixel value versus a high pixel value, the amount that the high pixel value is increased versus the low pixel value is higher, and that creates a bigger difference. And here once again we have a high limit of 255. It's a boundary. It's our boundary that keeps the image from basically fucking up. So it's the same as before. The next filter is the logarithmic image filter, or log filter, or whatever you want to call it. And what this one does, I'll show you here the code. What this one does is, once again we have the total pixels, so we go through them here in this folder. And what we do is that we set the output equals to simply the logarithmic function. This is a built-in function in NovaCV. We take that logarithmic function of the pixel variable, and in this case we time it by 20, because it would not be very visible if we did not. Show you example of this one. Wait. Take some time. There you go. Alright, here we go. Yeah, that's it. Creates a weird effect. Alright, so because it's so time consuming to do all these renderers, whatever you want to call it, to run the program every time, I'm not going to do it very many because it takes too much time. And the next filter is pretty much the same as the log filter. The only difference is they use the exponential function instead of the logarithmic function. I will not do that one because it's not necessary. This one's the gamma function, or the gamma filter. Alright, let's go. Here we assign the values to the gamma, which you can use later on. This one is of course the cloud and the header. Here we're not using the total pixels, instead using a double for loop. And what we do when we want to calculate gamma is we take the power, power of r, yeah, basically just say here takes a car value and takes it to the power, which we leave that up here, just 1.2, so it takes it to the power of 1.2. If it's less than Sorry. Yeah, it takes the power of double R. It takes the power of gamma. This is what this one means. The second one here, after the comma, is what you want to take the first one to the power of. So he would take R to the power of 1.2. And if it's less than 255, we're going to output it by setting the pixel equal to the power of gamma to R. We do that, and if not, we output max value 255. This is again to make sure that we don't get values be above 255. We'll do that for red, green, and blue. And that's very simple here. Another thing to notice is that we have to include math header, else this power function right here won't work. Alright. Yeah, my program just fucked up there. I can see we have 4 minutes left. So I'm gonna go quickly to the next one, solve Fibonacci. So what this one does is that once again it goes through all the pixels, and then we use the random function, and it produces a number between 0 and 100. Let's see. Yeah, so this variable right here is the one basically deciding how much solved Fibonacci is going to be. Because every time we random a number here, if it's lower than 5, you see it here, solved pepper, just this one is lower than 5, we set it to 0, which creates a black dot, black pixel. And here, if it's above 100 minus intensity, which is 5, so it's above 95, create a white pixel. And that's basically it. Also pretty simple filter using some random functions, and that's all pretty standard. This RGB2 grayscale is really simple as well. So all we do this is going to be the last one for go to the next video because we have a minute left. What we do here is change this from RGB to luminance. And that's it. That produces a grayscale image. I'll see you in the next video.